In this video we're going to look at where we can use the method of substitution to solve a linear and a quadratic equation simultaneously. So in this example we have x squared plus y squared equals 7, which you may, in fact should recognise as the equation of the circle, and y equals 3x minus 2, which is in a linear equation. So y is already the substitutive formula here, so we'll call that equation 1 and the quadratic equation 2. Now if the linear equation is not in the form where either x or y is the subject, then you need to rearrange it to make sure that it is first. And then you can sub the linear, so I'm going to substitute equation 1 into equation 2. So that becomes x squared added to 3x subtract 2 squared equals 7. And I can expand those brackets and then I can make it equal to 0, so x squared subtract 3x subtract 3 is 0, and now I have a quadratic to solve. And now ideally it would factorise, but in this case it won't, so I'm going to have to solve it using an alternative method, and I'm going to do this by the method of completing the square. And if you cannot remember how to complete the square, there is a video on this that you can locate. And I've rewritten 3 as 12 over 4 so that I can combine those two fractions together. When I root both sides, I need to remember it can be positive or negative. And that gives me two possible x values here. So 3 over 2 plus root 21 over 2, or 3 over 2 subtract root 21 over 2. And each of these is going to have a corresponding y value, which I need to find. And so that means there's actually going to be two intersections of the line y equals 3x minus 2 with the circle x squared plus y squared equals 7. So I'm going to do my substitution. So I'm going to sub x equals 3 over 2 plus root 21 over 2, and I'm going to substitute this into equation 1, and equation 1 was my rearranged linear equation. I'm going to rewrite 2 as 4 over 2 so then I can combine my fractions. And I've got my y coordinate. And I'm going to do exactly the same process in order to find the second one. So I'm going to substitute x equals 3 over 2 subtract root 21 over 2 into equation 1. Again, I'm going to rewrite 2 as 4 over 2. And I'll get y equals 5 over 2 subtract 3 root 21 over 2. And the thing you've got to be really clear about here is we had two solutions for x and we had two solutions for y, and we have to make absolutely clear which solution goes with which. So I'm going to do this in the form of coordinates. So the solution where x was 3 over 2 plus root 21 over 2 gave us a y coordinate of 5 over 2 plus 3 root 21 over 2. And my other pair of coordinates was when x was 3 over 2 minus root 21 over 2 and y was 5 over 2 subtract 3 root 21 over 2.